So there are three types of formulas. Those that are always true, those that are always false, and those that are sometimes true and sometimes false. The first one are called tautologies. The second, always false, are called contradictions. And the third one, we just call them neither, in the sense of neither tautologies nor contradiction. So how do we check whether a formula is a tautology, is a contradiction, or neither? Now consider the following formula. P implies Q implies P. Is this a tautology? Is this a contradiction, or neither? Now, in order to check whether it is a tautology, contradiction, or neither, the first step is to identify the atomic formulas, namely P and Q, that occur in this more complex formula. So we write them here on the side. We have P and Q. And we list at this point all the possible combinations of truth values for these two atomic formulas. They can be both true, one true and one false, either P true and Q false, or P false and Q true. And then finally, another combination is that they are both false. So these are all the possible combinations. We have 4 combinations. And the next step consists in evaluating formulas that are a little more complex than P and Q. And the goal is to get to evaluate our formula right here, namely P implies Q implies P. So that's the formula we want to evaluate. But in order to get here, it might be good, just for clarity, to get the truth value of this formula that is a little bit more complex than this formula here. So we write here Q implies P. So we need to evaluate that one first. Now, Q implies P. Now, if Q is 1 and P is 1, then this gets value 1 by the truth table of the implication. If Q is 0 and P is 1, then Q implies P is also 1. If Q is 1 but P is 0, then Q implies P gets value 0. And if both P and Q are 0, then Q implies P gets value 1. So that's what we have. Now we're ready to evaluate the truth value of this more complex formula here relative to all the possible combination of truth value for the atomic formulas P and Q. So we have P implies Q implies P. Now we have that P here, so the first row of the table here. So we give 1 to P, and then we have 1 to Q implies P. So this whole implication here is value 1. Then we have P again gets value 1, and Q implies P gets value 1. So this whole implication here gets value 1 as well. Now we have, in these last 2 rows, we have that P gets value 0. And so whenever P gets value 0, since P is the antecedent of our implication, what's lying on the left-hand side of the arrow, then the whole implication here gets value 1, regardless of the value of Q implies P. So since P gets value 0, then our whole implication here gets value 1. And so what we see, what's interesting here, is that this formula is always true. So is always true, no matter the truth value we assign to the various atomic formula. And so therefore it is a tautology, and we are done.